Okay, hello everyone. My name is Dr. Nagaraju, Assistant Professor, Department of Computer Science and Engineering, Artificial Intelligence and Machine Learning, Institute of Aeronautical Engineering, Hyderabad. Today I am here to present one of the most important topic of artificial intelligence and expert system, which is called as A-star search techniques. Along with A-star search technique, we are going to see two more concepts of artificial intelligence. So before moving into that one, I want to tell the objectives of today's session. Means we are going to cover three different topics. One is A-star search technique, and another one, second one is the problem reduction, and the third one is AO-star search technique. So as we know that the search techniques are of two different kinds. One is uninformed search technique, and another one is informed search technique. In the uninformed search technique, we are going to select a specific path blindly. Means during that process, what happens, we cannot guarantee that we are going to reach to the goal state. So that is one of the disadvantages that present in the uninformed search technique. And also in uninformed search techniques, means if you follow uninformed search technique to solve any kind of search problems, then we cannot guarantee that we are going to complete or we are going to reach to the goal point at the shortest period of time. So these are the two different disadvantages that present in the uninformed search techniques. So in order to overcome those problems, we are moving into the informed search techniques, where we are going to get a lot of information. Means we can say that we are going to get some additional information from the problem statement, which we can use in order to continue our search process. So what is that additional information is nothing but the heuristic values. Means here we are having a provision to apply some heuristic function which can provide us some heuristic values. Means by the help of those heuristic values, we can decide which path to select. Means the requirement of these heuristic search techniques, heuristic functions is needed whenever there are multiple paths from one point. Means as usually we can say that when there is two different paths from the initial state or from the current state, so it will be in a ambiguity that with what kind to which path we should move. So in that case, when if you take the help of heuristic function, apply it, and then you are going to get some heuristic value. Means when based upon the heuristic values, means if you are looking for the shortest path between the initial point and the goal point, then definitely we are going to select the path which is having the lowest heuristic value. So that is the advantage that present in the informed search techniques. So in the during our previous sessions, we have seen best first search as one of the informed search technique. So in today's session, we are going to talk about A-star algorithm and AO-star algorithm, and also one other concept which is called as problem reduction. So directly we will move to the concept called as A-star search technique. So as I said that it is an informed search technique which is going to be implemented as a combination of distance algorithm and the best first search algorithm. So the main intention of using this algorithm is we need to find out the shortest path between the initial point and goal point. So in order to find out the shortest path, the support whatever we are getting, it is called as heuristic function. Means we are going to take the help of heuristic function to generate the heuristic values. And this technique, we can say that it is going to find out the minimal cost value, or we can say it is a minimal cost solution, which is going to make us to direct towards some particular path. Okay, so in this case, why we are using this star means here star is nothing but the optimality. Means whenever you apply A-star search technique during your search process, you are going to get the best result. So we can say that it is the shortest path. Okay, so this algorithm is also going to find out the lowest cost path also. So as we say that it is the shortest path, then definitely we can confirm that that path is having the lowest cost value. And that too in between the same thing, that is in between the initial state and the goal state. So every time by considering this the lowest cost of the path, we are going to move towards one particular path in the graph, and we will try to move towards the goal state. Means ultimately our intention is to reach to the goal state by selecting the path which is having the lowest cost value. So the question is why we need the heuristic function. So already I mentioned that if you are having the heuristic function, then only you could able to get some values to you. that values are going to tell you which path you need to select. Okay, for example, think that from the initial state I am having two different paths. So the question comes is which path I have to select. So in that case, in the blind search or in uninformed search, you are not going to get any support. So that's why what we do, we randomly select one particular path and we will move in that direction. But we cannot guarantee that we are going to reach to the goal point, or if we reach us, it will not be the shortest time period, lowest time period we can say. So in this case, what happens, the need of heuristic function is definitely there. Why? Because when you apply some heuristic function, some heuristic values are going to get. For example, here the heuristic value we got 3 and here we got 4. That means that by observing these values only, whenever we are looking for the shortest path, then we are going to select the value which is having minimal. So in this case, what we can say, the 3 is having the minimal value. So simply what we do, we ignore this particular path and we will select this one. So when you go on doing this kind of thing, means whenever you follow this kind of approach, then definitely we can guarantee that we are going to get the shortest path. But when it comes to the A-star search algorithm, right, it is going to evaluate the cost. It is going to evaluate the cost of the path that passes through the particular state. Okay, in order to evaluate the cost, it is going to take the help of one particular function, mathematical function, which is called as this one, f of n equal to g of n plus h of n. Okay, means in every iteration, means at each and every point time when you are trying to change your states from the initial state to current state, or the present state to the next coming state, definitely at each and every point you need to calculate these values. So actually, what does this g of n and h of n means? Okay, as we are saying that g of n is nothing but the actual cost path from the starting state to the current state. Starting state to the current state. And similar to that one, if you take this h of n is also the cost only, the actual cost path from the current state to the goal state. Okay, we should not get confused in this particular point. Why? Because here g of n is nothing but the cost value from the s of ss, means which is called as starting state, and to the current state. Means, for example, think that this is the graph we are having, and the AI agent is here. So in this case, what happens if I say it is g of n? So g of n, I am telling that it is the distance, the cost between ss and cs. Means here it is, the value is already 3 is there here, and if it is 2, then what happens, the g of n is going to become 5 for this one. Okay, similar to that one, here the h of n is nothing but it is going to be it is going to give you the actual cost from the current state to the goal state. From the current state to the goal state. So in this particular point, we can consider that this one is the Euclidean distance. Okay, Euclidean distance. For example, my goal state is somewhere here. My current state is here. Means the AI agent's current state is here. So this g of n is going to give 5 to us, and this h of n is going to give the distance between these two particular points. Okay, so that is the thing, g of n and h of n, that is the difference. So whenever you combine these two values, you are going to get the f of n value, which is the actual cost from the starting state to the goal state. Okay, so this is the main important mathematical equation we have to apply every time while moving our positions. Okay, let us come to the implementation point of view. So during the implementations, as we did in the best of us search, similar to that one, here also we are going to take the help of two priority queues, or also we can say that we are going to represent those values in the form of arrays also. Here we are giving the names for those priority queues. One priority queue we are naming it as open, and another priority queue we are naming it as close. Now the question comes is what we are going to keep in the open priority queue and what will be there in the closed priority queue. So these two queues we are going to use in order to place the labels of the nodes. In open priority queue, we are going to keep the node labels which is going to state our current position. And the closed priority queue, in closed priority queue, we are going to keep the values which we have already visited. Means we are going to keep the labels of the nodes which we have already visited. Okay, so initially the labels of the nodes we are going to place in open priority queue, and then after completing the visiting, then we are going to move that node labels from open priority queue to the closed priority queue. So during this time, we are going to take again the help of heuristic value. So which one is having the lowest value, that we are going to select. And coming to the implementation, we are going to follow 6 different steps in implementation of this A star algorithm. So our first step is we need to find out the f of n value. We need to find the f of n value. Before that, whatever the initial node where we are starting our search process, the label of that node we need to place it in the open priority queue. Once it is done, next you try to find out the f of n value. After getting the f of n value, then you need to change that node label which you have kept in open priority queue, that you have to shift it to the closed priority queue. So that's why what we are saying is, in step number 2, we are going to remove the node from open priority queue which is having the smallest f of n. Then if it is the goal node, see, it does not mean that every time we are going to shift the node labels from open priority queue to closed priority queue. But before moving, we need to compare those node label with the goal label. Okay, for example, if our goal state is the same, which is matching with the label that present in the open priority queue, that means that we have reached to the goal point. So it does not make any sense when we continue our search process. So that's why whenever we are trying to move a node label from open priority queue to closed priority queue, you should make a comparison. Means you have to compare it with your goal state. If it is the goal state, just place it in the priority queue, closed priority queue, and close your search process. So this entire process we are going to continue until and unless we reach to the goal point or goal state. Coming to the advantages of A star algorithm is, as I mentioned, that the results of the A star algorithm implementation is optimal. Means whenever we compare the results of this algorithm with the results of other algorithm, definitely we can say that this is the best result. Why? Because it is successful in identifying the shortest path, or otherwise we can say the optimal path between the initial state and the goal state. That's why we say that every time when you compare this algorithm with the other algorithms, this algorithm is the best one. And it is also going to solve very complex problems also. Okay, so it is optimally efficient also. Means there is no other optimal algorithms guaranteed to expand fewer nodes than A star. Means when you look in any of the angles, we can means whenever we are trying to compare this A star algorithm with any other existing algorithms, at any mean, definitely it is having some sort of advantage only. Let us try to take one simple example, and we will try to understand how this A star algorithm really works. For that case, what I have done is I have taken one simple example which is called as here the graph. Okay, here I have considered a graph. So what is our task? Our task is we need to identify the shortest path between the initial state and the goal state. So according to this graph, the initial state is A. The initial state is A. And what is our goal state, or what is our final state? F is our goal state. F is our goal state. So our primary duty is we need to find out the shortest path between the node A and F. So what is the support we are getting? Means what is the additional information we are getting from the problem statement? Means we are going to get the heuristic values. Why? Because this A star algorithm is a informed search algorithm. So you are going to get some heuristic values, and you are going to make use of 2 priority queues, which is called as open, and another one is called as closed. Along with this, again you are going to get one more value which is called as the cost. Means during our traversal, means moving from one node to another node, we are going to consider the lowest, the path which is having the lowest cost itself. And here the considerations, when it comes to the considerations, we are considering the heuristic values as the distance. Distance is nothing but some Euclidean distance. Means, as I mentioned, Euclidean distance means it is the distance from the current state to the goal state. Okay, whatever will be your current state. Okay, so this is the considerations we are having. Let us try to implement the algorithm and see how it works. So these two things you observe here in this diagram. I am giving two different examples. So this is a figure, okay, which I am talking about the graph, or otherwise we can say that it is a search space. It is a search space. So in this search space, our motto is we need to find out the shortest path between the A and G. So what is the support we are getting here? The support is the values. Okay, so what are these values are telling? So these values are representing the distance, we can say distance between one node to another node. Means, for example, whenever I mention 1 here, I mentioned 1 here. That means that 1 is the distance that is going to take, or that is going to cover in between A and B. Similar to that one, whenever I mentioned it as 10, that means that it is the distance from A to F. Okay, so we can consider that this is the heuristic value, but it is not the Euclidean distance. Why? Because Euclidean distance means the distance from the current node to the goal node. So that heuristic values in the form of Euclidean distances we have represented in this table. Means, whenever I mentioned A5, that means that the Euclidean distance from A node to the goal state is 5. Okay, so these are the two different values we need to consider, and we have to take the help of the same mathematical equation, that is f of n equal to g of n plus h of n. And we will try to see how we can solve the problem and how we can identify the shortest path. Come to this one. Here what happened in the initially, means in the first step, I am trying to identify the path. So as we are observing here, from A, we are having two different paths. We are having two different paths. Here the question is which path we need to select. To determine that one, to decide that one, we are going to take the help of this equation. So in this case, means whenever you substitute the values of g of m and h of n, what happens? It will becomes 1 plus 3. So how it is 1 and how it is 3? So as here you can observe the distance from A to B is 1. So here I have mentioned 1. And from the table, right, it came to know that from node B, okay, we are having value 3. That means that from node B, okay, the Euclidean distance to the goal node is 3. Okay, so it will be 1 plus 3. So the answer will be 4. Similar to that one, means here we have calculated and we came to know that the f of n value for this particular path is 4. Similar to that one, we have to calculate the f of 1 for this path also. So how can I do it? The same thing, right? What is that? 10. So here we can see that the value is 10, means that is the distance between A and F is 10. So I have represented the 10 here. Means, and the next is h of n. H of n means your current state will be this one. So the distance between this node to this node, obviously we say that it is 0. So what happened? It became 10 plus 0, that will be 10. Okay, that means that the f of n value for this particular path is 10. But as we know that whenever this kind of situation occurs, we are going to select the path which is having the lowest f of n value only. So obviously when we compare with the 10, 4 is the lowest value. So just we are going to ignore this particular path and we will move in this particular direction. Okay. Now this is the case. So what is our position now? Our position is at B. Our means here the AI agent's position is at B. Now the same thing, from B, how many possibilities are there again? There are 2 possibilities. Means there are 2 paths available. So which path we need to select? Again we have to calculate the f of n values for both the paths. So in this case what happens? It will be like this. Means already we moved from A to B. Then after we are trying to move towards C. But before moving, we are calculating the f of n value for this particular node. So what happened? It became 3 plus 4. Then the answer we got is 7. The same thing. 3 will be the distance. You try to observe here. So how this 3 came? Okay, how this 3 came? You try to observe. As I mentioned, g of n is nothing but the actual cost. Means which is nothing but the distance from the starting state to the current state. Okay, so what will be your current state in this step? Your current state will be this one. So g of n is going to be the distance between the starting state. What is your starting state? This is your starting state. From the starting state to your current position, what is the distance? So it will be 1 plus 2. Why? Because the distance from A and B, distance between A and B is 1 and the distance between B and C is 2. So obviously what happened? It became 3. So 3 is nothing but here the g of n value. Come to the h of n. H of n is nothing but the Euclidean distance. Means from the current position. What is your current position here? C is your current position. From the current position, what is the distance to the goal state? Okay, so it will come to know from the table. Okay, in the table what we have observed, it is 4. So what happened? It became 3 plus 4. So the answer will be 7. Okay, similar to that one, right? This is for this particular path. For this particular path, we got 7 as a f of n value. Now similarly, we have to calculate the f of n for this particular path also. Means initially it became a to b and b to c. So the f of n value we got is 7. Now we need to calculate from a to b and b to d. Why? Because b to d is also there is another possibility for us. We cannot guarantee that that may be the whether that is the shortest path or not. Until and unless you find out the f of n value, you will not come to know. So wherever we calculate the f of n for this particular path, what happened? It became 4. We got the value as 4. So here the f of n value for this particular path will be 4. Now you do the comparison. So what happened here? Here the f of n value is 7 and the f of n value is 4 here. So which one we are going to select? Optimally, we know that if you want to get the optimal result, then you have to go for the lowest value only. So in this case, we are going to select this particular path. Okay, so that means that your current position is not this one now. Your current position will be this one. Okay, we will try to see it. Okay, so we are in the current position D. Means our current position is at node D. So again, what happened from this node also there are two possibilities. Means there are two different paths. Again, we have to calculate the f of n value. So whenever we calculate the f of n value from D to E, okay, for the path which is present from between D and E, so what happened? We got the value as 11. We got the value as 11. And when you do the calculation for f of n for this particular path, D and F, what happened? You got 4. So obviously what happens? We are going to select the lowest value only. Why? Because we are looking for the optimal path. So simply in this case, we are ignoring this. Here, what happened? We ignored this value, so this path. Okay, now we are ignoring this particular path. Means we are not going to move from D to E. Why? Because it is having the highest f of n value. So simply ignore that particular path and select this one. Why? Because this is having the lowest f of n value. So what happens when you follow this one? Now your current position will be this. Means the AI agent's current position will be this. So see, every time what we are doing the comparison, right? That you should not supposed to forget. Means when you change your position from A node to B node, so if your current state is this one, you need to make the comparison that whether your current state is equal to the goal state or not. If it is equal to the goal state, you have to stop your search process here only. Okay. But what happened when we came to B, we did the comparison as per the A star search algorithm. So we came to know that both are not same. Means the current state and the goal state are not same. So what we are doing? We are continuing our search process. And also here in this case also, when we move to the D node, again here also we are going to do the comparison between the current state and the goal state. So again the same thing, means during our comparison we will come to know that these two are not same. So that's why we continued our search process. So ultimately what happened, we came to here. So here what we will do, we will try to do again the same comparison process, comparing the current state and the goal state. So what happened here, the current state is F and we are also at F, means our goal state is also F. So in this case we can say that we have reached to the goal point. We have reached to the goal point. So how it will be represented? It will be in this fashion. So the shortest path or the optimal path, whatever we find out between the A node and the G node, means between the initial node and the goal node, is this one. The same thing, right? Again I am repeating this. From A we move to B, and from B we move to D, and from D, sorry, this will not be there. Okay, from D we are going to move to F. Okay, so this will be the shortest path. Okay. Like this, the A star search algorithm is going to support us in identifying the optimal path or the shortest path between the initial state and the goal state. Okay, even though there are a lot of advantages present in A star algorithm, there are few disadvantages. Of course, we can ignore these disadvantages, but anyhow, we need to cover them. This algorithm is complete, right? We can say that this algorithm is perfect whenever the branching factor is finite. And also every action has a fixed cost. Definitely you should have some value, some cost value. Okay. And the speed of the execution of this A star algorithm is completely dependent. Okay. Dependent on what? Dependent on the accuracy of the heuristic algorithm and also in calculating the h of n value. So we can say that it is having some complexity problems. So in order to overcome these disadvantages, again we are going to study some other algorithms. Okay. So these are the references which I have used for preparing the content for A star algorithm. And coming to the next one, our objective, the second objective is problem reduction. So problem reduction is one of the other technique through which you can solve artificial intelligence kind of problems. So generally what happens when there is a complex problem, right, in general we will try to split that problem into sub problems. Means directly solving the complex problem, it is going to take long period of time. Means time complexity is going to come as well as the space complexity. So in order to overcome that one, we are going to split or we are going to divide that complex problem into sub problems. And we will solve those sub problems first. We will get the results of those problems and we will combine them to get the result of the main problem. Okay, so this is called as here the problem reduction. But during the time of problem reduction, there is a possibility of generating some kind of arcs, we can say. There is a possibility in generating some arcs. So what is happening? We can say that the problem reduction representation is a kind of structure where we are going to represent a tree. Where we are going to represent a tree which will be in the form of AND OR graph. So what advantage you are going to get if you represent in this fashion means they are very useful in order to represent the solution for any problem. Okay, so these problems can be solved as I mentioned by decomposing them into the smaller problems. So during the time of decomposition, what we are going to get? We are going to get some AND arcs. Okay, let us try to see one simple example. Okay, one AND arc may point to any number of successor nodes. Okay, so what does it mean? For example, think that this is your complex problem. This is your complex problem. You have divided this complex problem into 3 sub-problems, let us think. 3 sub-problems. So what happened? You came to know that this sub-problem, okay, this sub-problem, problem 1, this sub-problem 1 is completely independent to achieve this particular problem, to achieve the solution for this particular problem, right? So you keep it individually, you will keep it individually, but you came to know that the sub-problem 2 and the sub-problem 3 both are dependent to each other. So what happens here? You are going to keep an arc. So what that is, this arc will tell the and this is an and arc. This is an and arc, means if you want to solve this problem, that means that you have to solve the subproblem 2 and subproblem 3. Then only you can come to know that you have solved the main problem. Okay, what does it mean? We can think that these are some kind of dependencies. Means SP2 and SP3 are dependent to each other. Until and unless you solve this SP2 and SP3, you cannot solve this one. Okay, we will try to see some example. Okay, so this is the example. You see, what is our goal? Our goal is we need to acquire the TB set. We need to acquire the TB set. So, 3 different arcs are there in this. Okay, so sorry, 3 different paths are there. In this, we can say that this is a R. Why? Because this complete sub goal is completely independent. Means what is its goal? Just to steal the TB set. But if it is not the case, so what happened here? We have represented a AND arc. Okay, this is called as AND arc here. What is this AND arc is telling here? You see the goal. What is our sub goal here? We need to end the money first. Okay, we need to end the money. So this is our first sub problem. We need to end the money, means we are going to solve that sub problem, and then with the money what we got, we are going to buy a television set. When you buy it, that means that you have acquired the television set. So in this case, what is happening? Until and unless you earn some money, and until and unless you buy it with your money, you cannot say that you have acquired the TV. Okay, like that it will be. Means during the problem decomposition, there is a possibility of generating this and arcs. So if you want to solve these kind of problems, you have to solve these things before, and then after you have to come up. Okay, and also the main thing is the algorithm should have to find out a path from the starting state of the graph to the set of nodes presenting the solution states. Okay, and come to the example here. So what happened? We started from a particular point which is called as A and which is having some value 5. So in the second step, what we have done? We have tried to generate the successors of that particular node. Okay, so what are the successors? We are having B, C and D. We are having some B, C and D. Okay, so what are the values we are having? For B it is 3, for C it is D, and for D it is 5. Okay, so what is the what is the things available here? It is an R and it is the AND arc. AND arc means if you are moving in this particular branch, definitely B and C need to be considered. B and C need to be considered together. So in this case, the question is how this 9 came. So what happens is by default, each and every path is going to have a value of 1. So this path is having 1 and this path is also going to have 1. So what happens? The value of this one is 3 and plus 1, the path default value, and the value of C is 4 and the path value is 1. So what happens? It will become 9. Okay, like this we are going to represent. Means if it is the OR, you should not supposed to do these kind of calculations. As if there is an AND, we are doing that one. Okay, so after decomposing, what happened? You need to do the comparison. So what happened here? 3, 4 and 5 are there. 3, 4 and 5. So which one is the lowest well? Okay, what is the lowest one? Here we are having 9, but here there is only 6. That means that this particular branch is having the lowest value. So what we will do? We will try to select this particular node and we will try to generate the successors for D. So in the next step, we have calculated the successors for D. Once it get done, so again the same thing, how the 10 came here? 4 plus 1, this one, and then plus again this 4 plus 1. So what happened? It will become 10. Okay, so this is the value. So now you do the comparison. So what happened here? 9 and 10. So which one you are going to select? Why? Because 9 is the lowest value, so you are going to select this one. So you will try to identify, or you will try to generate the successors nodes for B now. Okay, like this the process is going to continue. Okay, coming to the AO star algorithm. Okay, that is our third objective in this session. So the AO star algorithm's main intention is it is completely knowledge based. It is completely knowledge based, and also the main advantage is here again the same thing. The initial state and goal state are already defined. It is already defined. Only the thing is, by taking the help of heuristic values, you need to find out the best path. Means you are going to see some same kind of similarities between A star algorithm and the AO star algorithm. Why? Because both comes under informed search techniques only. Okay, so the time complexity of the algorithm is significantly going to reduce. Means the main advantage of AO star algorithm, we can say that it is going to reduce the time complexity. And it is also, means this AO star algorithm is so efficient in handling and or trees very efficiently. Okay, the same thing, right? It is also going to take, means this algorithm is also going to take the same kind of formula which is called as f of n equal to g of n plus h of n. The same thing, g of n is going to be the actual cost between the initial state and the current state. And h of n will be the estimated cost of traversal. Only the thing is, we are not saying it as just cost, we are saying it as estimated cost of traversal. So from where to where? From the current state to the goal state. And the same thing, f of n will be the same actual cost of traversal from the initial state to the goal state. So there is no difference in representation of these g of n, f of n, h of n when you compare it with the A star algorithm. Okay. So we will try to take one simple example and we will try to understand. So this is a tree given to us. Okay, what tree? It is called as a and or graph, or otherwise we can say it is a and or tree also. And or tree. So what happened here? It is completely the or. Why? Because it is this path is completely individual, but here you can see one arc. So this arc represents it is and here also one arc is there. Means it is and. Means in this case what happens? You have to solve this one and also you have to solve this one. Then only you could able to solve the main problem. And in this case also, you have to solve both H and I, then only you could able to solve C. Okay, so coming to the values. Okay, the values that present that we have kept in the brackets, they are nothing but the heuristic values. And as I mentioned, each and every path is going to have one default value, a default value which is 1. Okay, so that means that here for this one there will be 1, for this path and this path, this every path is going to have some default value 1. Okay, so what does this zeros represent here? So whenever these zeros are represented, that means that these are already the solved one. It's not necessary to move further from this place. Only it's not you should supposed to consider the other nodes. Means from this diagram we can say that these two are already solved and this is also solved. Okay, now we will try to extract how this algorithm generally works. Okay, in step number 1, what we do, we will start from the node A. So at that point what we do, we will try to identify or we will try to calculate the best path by using the same formula, that is f of n equal to g of n plus h of n. Okay, so in the second step, by using the same formula as step 1, we are going to find out the path. Means the path we are going to calculate from the node B. Why? Because after applying the formula, we have reached from node A to node B. That indicates the completion of step number 1. In step number 2, again what we are doing? We are doing the same thing. That is applying the formula f of n equal to g of n plus h of n. Okay, so like this. So this is our initial diagram. You have to think in this particular fashion. So what happened here? The values are represented as 5 and 7. As we know that how we got the 5, means the value given for us is here 4. So the default cost is 1 here for this one. So it will be 4 plus 1. The answer will be 5. The answer will be 5. So similar to that one, here we got 7. So as we know that 5 and 7. So in this case, which one we are going to pick up? The value which is having the lowest one. I mean the lowest value one path we are going to select. So our next diagram will be this one. Okay, so here also the same thing. So what we have done, we have moved to the node B and we started calculating the same one. So again, in this case, what happens? It will become 7 and 9. So then we can, the minimal value. So we are going to replace, or we are going to erase the earlier 4 and we keep 7 there. And come to the next one. So what happened here? Now again the same thing. So we calculated for each and every node. Sorry, for each and every path. So here what happened? It became 3. Why? Because it is 2 and here default value will be 1. Default value will be 1. So it is 3. So here they are already solved. That's why we are having the values 0 and 0. That means that we are going to consider only the default values of this path. 1 and 1. So that's why we got 2. 1 plus 1 as 2. Okay. Similar to that one, if you go here, what happened? This is 2 and this is 1. So what happened? It became 1 plus 2 and the value of this one is 1 and the default value for this path is 1. So again it will become 1 and 1. So the answer will be 5. So we are going to update this 7 with value 5. Okay. So then we can say that we have solved the problem, okay, by identifying the path from A to C and C to D. So these are the references I have considered during the preparation of the content. Thank you very much. We will come with other topic in the next coming session.
Like, share and subscribe. Hit the bell icon for more updates.